All right. So, welcome back to our test video for right triangle trigonometry. So, here we will have the part 4 of this test. So, here it basically consists of finding 6 trigonometric ratios in a given right triangle. All right. So, what we're going to do is just more likely problem solving. All right. So, there's no true or false and whatnot. That's just similar as a third test. All right. So, without further ado, let's begin. So here, we will find all the 6 trigonometric ratios in a given right triangles based from a given acute angle. So we have this first right triangle here. So again, recall all of the 6 trigonometric ratios. So let's start first with, of course, the three basic trigonometric ratios, which are sine theta is equal to opposite all over hypotenuse. Next is cosine theta, which is adjacent all over hypotenuse. Forgive me, I'm trying to clear my throat. Then next we have tangent theta, which is opposite all over adjacent. All right. Then next we have the other three. I do believe it's the reciprocal trigonometric ratios, which are cosecant theta is equal to hypotenuse all over opposites. Then secant theta, we have hypotenuse all over adjacent. And lastly, for cotangent theta, it's adjacent all over opposite. Mm. So now that we have this given trigonometric ratios, so what we're going to do is we're going to find those ratios for each trigonometric functions. Trigonometric function, yeah. Right. So anyway, let's begin. Before that, we need to label the parts of the right triangle, all right? Which one is the hypotenuse, the opposite, and the adjacent? The hypotenuse is very, very obvious, which is the most likely the diagonal side or the longest side. So 35 meters. This side right here, this is what? This is your hypotenuse, okay? This is your hypotenuse. Now, how about opposite? How about adjacent? Opposite sides, opposite side and adjacent side are the legs of your right triangle. So these are like the legs. But the question is, which one is your adjacent and which one is your opposite? So remember that adjacent side, it is called adjacent side because it is adjacent to the given acute angle or the acute angle we are referring to. Okay? So in this case, we have a given acute angle. And the only side that is adjacent to it is 30 meters. When I say adjacent, it's basically another word for beside to. So therefore, the base side, which length is 30 meters, that is your what? Adjacent. That is your adjacent. Now, on the other hand, what if we have a side that is not beside to the given angle? Like the vertical, the height of the right triangle, basically. Then that is your opposite. 90 meters is your opposite side. All right? So now we know the hypotenuse, adjacent, and opposite. We can now find the trigonometric ratios. Let's start first with sine theta. So opposite all over hypotenuse. So we will have 90 meters all over 35 meters. Okay? And we have meters on both sides, so we can just cancel them. So as a result, we will have this. All right, we will have 19 all over 35. Right, 19 all over 35. This is, wait, you know what? Let me rewrite the number 3. There we go. Now, for cosine theta, we have adjacent all over hypotenuse. So, adjacent is 30, hypotenuse 35. We can simplify this fraction because you see 30 and 35, they are both divisible by 5. 30 divided by 5 is 6, and 35 divided by 5 is 7. Hence, instead of writing 30 all over 35, we can simply rewrite its simplified form, which is 6 all over 7. Much better. Now for the tangent theta, opposite all over adjacent. So we will have uh 19 all over 30. There we go. For cosecant theta, it's just basically the exchange position of the ratio of the sine theta. Because remember, cosecant theta is the reciprocal of sine theta. So if we have O all over H, for cosecant theta, we will have instead of OH, it's HO, H all over O. So what we will do is we will just exchange the position of the equivalent ratio of sine theta. So instead of 19 all over 35, we will have 35 all over 19. Or if you don't understand what I'm trying to imply, just simply follow this formula. All right. So we have this one. Now for second theta, so here we will have 7 all over 6. Okay. And if you are asking me how did I get 7 all over 6? Well, the thing is, we have a hypotenuse of 35, right? Then we have an adjacent of 30. But 35 and 30 are once again divisible by 5. 35 divided by 5 is 7. 30 divided by 5 is 6. Hence, we will have 7 all over 6. And lastly, for cotangent theta, we have adjacent all over opposite. So here, we will have 30 all over 19. So these are your trigonometric ratios in this right triangle. Easy enough, right? Now, let's proceed here to the next problem. Here we have a given right triangle, but you see, there's actually, no, there are differences between this and this. First difference is the location of the given acute angle. The given acute angle here is on the top, which is beside to the what? The height of the right triangle. On the other hand, it's basically on the base, right? Second is we have one missing side. Compared here, it's complete. So what are we going to do in this case? So for us to find all the trigonometric ratios, we need to find the missing side, right? We need to find this. This is important because you will not able to find other, if not all, other trigonometric ratios if we have a missing side. So how can we find the missing side? We will use Pythagorean theorem. All right. But before that, let's label the sides first. Okay. Just like what we did on the first part, we label which one is hypotenuse, which one is adjacent, and so on and so forth. So we will do that here. So again, the very obvious one, the hypotenuse is the longest side, the diagonal ones. So this is your hypotenuse. All right. Now next, we have the legs, all right? But again, legs have their own specific name. Is it opposite? Is it adjacent? We will see. So here, since we have a given acute angle above, that means that this vertical side is beside to that angle. So therefore, this is not opposite, but rather adjacent because again it is beside to the angle. Remember, I'm trying to make you guys remember that, or to remind you that adjacent is about adjacent to the angle, or it's beside to the angle. Now how about this one? Since it's not beside to the angle, we can simply say that this is what? The opposite. So now we need to find the length of your opposite side. So we will use Pythagorean theorem. And remember that in Pythagorean theorem is the sum of the squares of the leg. I mean, sum of the squares of the leg is equal to the square of the hypotenuse. So we will have a squared plus o squared is equal to h squared. So your a squared, we will have the square of 42 inches plus o squared is equal to 123 inches squared. So let's find your o. So first, let's get the squares of the two numbers, right? So let's start first with 42 squared. 42, wait. Yeah, 42 squared is, wait, you sure? 42, okay, okay. 42 squared is 1,764 inches squared. Don't forget to square the inches, by the way. All right. So plus O squared is equal to the square of 123. So this would be S squared 15,129 inches squared. So let's find our O. So just transpose this one to the right. We will have O squared is equal to 15,129 inches squared minus 1,764 inches squared. All right, there we go. So this would be, if you're going to get the difference between the two, so 15,129 minus 1,764, that's 13,365, right? So 13,365 inches squared. So what's next? We will square both sides to find our opposites. So in here, if you think that the answer is in decimal, I think it's better to leave it at two decimal places. Okay. If and only if the answer is it has a decimal value, all right? It's better to end it at two decimal places at least. So for me, I'll just pick until two decimal places. So if we're going to get the square root of 13,365, we will have approximately 115.61 inches. So that is the length of your opposite side, 115.61 inches. All right. So now that we found it, so let's now find our trigonometric ratios. Okay. So can I just copy this? Wait, hold on. Can I copy? Alright, good. So I can just simply copy the trigonometric ratios and I'm just gonna erase the answers here. There we go. Alright, so this one is pretty easy. All you need to do is find opposite hypotenuse and we're good to go. So here in sine theta, we have an opposite side of 115.61 all over your hypotenuse 123. Let me take a look if I can simplify this. Is there by chance we can simplify this? 123. So, nah. I, it's like that. Anyway, next we have cosine theta. So cosine theta is 42 all over 123. All right, let me take a look again if we can simplify that fraction. 42 all over 123. Yes, we can simplify this one because this can be rewritten as 14 all over 41. All right? Because, what do you call this one? Wait. Because 42 and 123, I think they are both divisible by 3. Let me check. 123 divided by 3. Yeah, these two numbers are both divisible by 3. So 42 divided by 3 is 14 and 123 uh divided by 3 is 41. So therefore, we can have 14 all over 41 instead. There we go. Right, next for this one, opposite, we will have 115.61 all over the adjacent 42. Yeah, 42. Right, there we go. Now we will find the cosecant theta. So we will have 123 all over 115.61. Here we will have for secant theta 123 all over your adjacent, which is, what's that again? 42. And lastly, for cotangent theta, we will have 42 all over 115.61. And those are our answers. Oh yeah, by the way, for second theta, we can simplify this as 41 all over 14. Wait, let me check if I can simplify for the tangent and for cotangent. 115.61 divided by 42. Is it possible for me to simplify? Nope. So we're just gonna leave it that way.